Now that we've learned how to multiply like bases and even divide them, we're going to learn how to multiply monomials. Monomials, of course, is a little bit more than just a base. A monomial also has a coefficient, so we have to take that into account. However, the steps are going to be very similar. As long as you've studied that previous lesson and mastered that, you'll be good with this one. Remember, a monomial must have a whole number exponent. If it does have an exponent, if it's not a monomial. But sometimes in these lessons, we do include negative exponents just because the rules are the same, so just keep that in mind. The rules are the same. We could also call this lesson multiplying single terms, pretty much be the same thing. So I want to show you something that's going to lead us to why we can do what we do here, and that's the order in which you multiply numbers. If you take 6 and multiply 4 and 3, let's do it one way. Let's do 6 times 4 first, which is 24. Then multiply 3 and you get 72. Now notice that we could do 4 times 3 times 6. 12 times 6 also gives us 72. Or we could do 3 times 6 times 4. What we're getting at is the order in which you multiply numbers does not matter. And that goes back to the commutative property. Commutative property means the order in which you multiply or even add doesn't matter. This works the same for variables. If I had x times y times z, it'd be the same as if it had z times y times x or x times z times y. They're all numbers, so the order in which we multiply them does not matter. So when multiplying monomials, you can reorder things as much as you want, and it won't matter. And so we want to reorder things sometimes in order to see that in order to multiply like bases and multiply the coefficients, we can do that because of the commutative property. The order in which you multiply numbers doesn't matter. For example, 3x squared y, does that equal 3yx squared? Well, what we're going to demonstrate is, in fact, it does. If we break down the x squared, that's just x times x. If we break down the x squared over here, it's x times x. Now notice that you can take the x times x and move it to the left of the y because of this commutative property. And then when we rewrite it, 3x squared y, we get the same thing over here. We also get 3x squared y. And that shows you that even if the monomial has an exponent, you can quickly move it to the left or move it to the right or however you want, and it's the same thing. So this demonstrates that you can reorder a monomial into whatever order you want it to reorder, and it will be the same monomial. And that will help us multiply monomials. Let's go ahead and take a look at the first example. 5x times 10x. What I want you to do first, and you do this at first, eventually it'll just become really easy. This helps a lot of students when they're first working these problems out. Just put a multiplication sign between every single component, because 5x is the same as 5 times x. We talked about that. 10x is the same as 10 times x. Again, once you get going with these things, you don't have to do this every time. Now that we fill in the missing multiplication signs, we're going to fill in any missing exponents. So we know that x is the same as x to the first, so we're going to put a 1 for both of those x's. Now we're already alluding to what we're going to do next, and that is we're going to group the numbers. Again, we can do that because the order in which you multiply numbers doesn't matter. So in this case, we're going to put the 5 and the 10 together. They were both the coefficients, but they're numbers, so we're going to put the constant numbers first, followed by the variable terms next. All right, so now that we have the numbers together, leads us to step 4, which basically takes care of itself once you group the numbers in this example. Of course, if we had x, y's, and z's, we want to group the x's and with the x's, y's with the y's, and z's with the z's. But for this example, we've already got that done. The x terms are grouped, so let's move on to the next step, which is just multiplying the numbers. Okay, and so 5 times 10 is just 50. That's step 5. That's all you have to do. Just multiply those numbers together, and that's why we reordered them, just so that we multiplied them correctly. Okay, you're going to learn when you do math, the more steps you do, the less mistakes you make, and that's what we're doing for now. Now again, once you do these after a while, you don't have to do that long way every time. You'll get so good at it that you can almost do it in your head. But for now, let's definitely show it work. Next step is to multiply the like bases. We've learned that in the previous lesson that you add the exponents. So 1 plus 1 is 2, so therefore the answer is x squared. And the last step is to get rid of that final multiplication sign. So 50 times x squared is just 50x squared. So that's it. We started out with 5x times 10x, and the final answer was, or is, 50x squared. Let's take a look at the next example. We have negative 3x squared y to the fourth z times 10xy squared z to the ninth. Now, when you're adding and subtracting monomials, they have to be the same. You can already see that they don't have to be the same in order to multiply them. Okay, and we've already shown why that multiplication rule works. So just differentiate those two rules. Let's go ahead and do this one. I'm going to go ahead and put a multiplication sign in between every number and variable, just so we're clear about the different components. So that's filling in the missing signs. Now we're going to fill in the missing exponents. So the variables that don't have exponents, we're going to put a 1 there, 1 for the z, 1 for the x. There we go. Next step is already alluded to. We're going to group the numbers together. So group the negative 3 and the 10. All right, that's fair. Next step is going to be grouping the like variables. So basically, we're going to put the x's together, x squared, x to the first. We're going to put the y's together, y to the fourth, y squared. We're going to put the z's together, z to the first, z to the ninth. It's going to look like this. Okay, there's the x, y's, and z's. And you can see why we do that, because now it's going to be really easy to multiply all this stuff together. So first we're going to do negative 3 times 10. In other words, we're going to multiply the numbers together. That's negative 30. And then for step 6, we're going to multiply these variables, or these bases, and we're going to add the exponents. So first of all, x squared times x to the first is x cubed. Y to the fourth times y squared is y to the sixth. Z to the first times z to the ninth. 1 plus 9 is 10. There you go. There's step 6, multiplying like bases. I can promise you when you first start doing these, you're going to get the problem right almost 100% of the time if you just group these first. Now, like I said, once you get comfortable with them and you're really sure of yourself, then maybe at that point you can add the exponents and stuff without grouping them. But if you have time, why not? You might as well group them. And then this one's already simplified, so that completes step 7. Let's look at another example. We have 2/3 x cubed y cubed times 0. Now, you might already kind of see a shortcut here. Anything times 0 is something, but let's go ahead and do our work. All right, so we're going to group the numbers together. There are no missing exponents. We're going to group the 2/3 and the 0. What's anything times 0? Okay, it's 0. Variables already grouped together. There are no x and y. You can't multiply together, so just leave it that way. But 0 times anything is 0. Okay, so what happens here is, all right, there are no like bases to multiply, but guess what? 0 times anything is 0, so when we go to simplify this, we get 0 back. What I was showing you with this example is it doesn't matter how big the monomial is. If you multiply 0, you're going to get 0 back. So keep that in mind. Next time you see that, you can use that shortcut and you just have 0. I want to do another example here. We have negative 2/3 a to the pi b to the first times, well, actually the 1 wasn't there to start with. I guess we'll go ahead and assume it's there, times 9a to the pi b to the negative 3. So I'm doing this for a couple reasons. I know the name of this lesson is multiplying monomials, but when you're multiplying like bases, it doesn't really matter whether it's a monomial. The rule is the same. Okay, when you have like bases, you add the exponents. So we're going to see that as we apply that rule. This one's going to be a little bit more advanced, but I wanted to show it to you because you will see it in the future. First thing we're going to do is group, or actually we'll go ahead and just multiply the constants together, the coefficients. Negative 2/3 times 9 is negative 6. Okay, 2/3 of 9 is 6, and it's negative, so it's negative 6. But then we can see what? A to the pi times a to the pi. What we're going to end up doing is adding the exponents. Pi plus pi is 2 pi. Okay, I know that looks a little weird, but again, the bases are the same. They're both a. So all you have to do is add the exponents. Pi plus pi is 2 pi. This is bothering me, so I'm going to change it. Okay, there wasn't for the original problem, there wasn't a one there to begin with. So it was actually just b. So when there is no exponent there, you need to add the 1. Okay, so that's why I had a 1 there. So we have b to the first times b to the negative 3. 1 plus negative 3 is negative 2. So that takes care of the coefficients, the a's and the b's. Now we're going to simplify that. Since b is negative, we're going to make it positive and put it under the bottom of the fraction. Okay, and so the last step, which is simplifying, is very important. If you have a negative exponent, you need to make it positive and put it under 1 if it's by itself, but in this case there's already stuff up here, so we make it positive and put it under the fraction. There's a lot going on in this example, but we've already learned everything we need in order to succeed, in order to get this problem right. We added the pi's to get 2 pi. That was a little different, but it's the same rule. And we took this negative exponent, we made it positive, we put it under the fraction. So that's multiplying, actually multiplying monomials. They don't have to be exactly the same. In fact, in many cases, they're going to be very different. Just remember to multiply the coefficients or the constants, multiply like bases. When you first do it, make sure you group them, like I said, first, and after you get comfortable, you can maybe skip that step, although I think you should always regroup when possible. And so just group those together and then multiply the numbers and the like bases together, and you're going to get the right answer every time. So that's multiplying like multiplying monomials. Keep saying like monomials. They don't have to be like to multiply them. They just have to be like if you're adding or subtracting them. If you have any other questions about multiplying monomials, let me know.